Okay, so you want to own a bottled water factory. You picture clear water moving through stainless steel pipes, perfect bottles appearing faster than you can count them, cases stacking themselves onto pallets, and trucks leaving for stores with a product people already buy every day. No complicated recipe, no seasonal fashion, no customer who needs the idea explained. Water goes in, bottles come out. The difference looks like profit. Now put one more image beside that. A factory covering almost 432,000 square feet. More than $115 million invested. 3 production lines. Roughly 120 full-time employees. And one large retailer's order occupying most of next week's schedule. That retailer calls on Friday and asks for a lower price. You can say no and leave part of the factory idle. You can say yes and keep the machines moving for less money. Or you can chase another customer farther away and discover that the truck takes what the production line saved. That is the business hiding behind the bottle. The hard part is not finding water and putting it in plastic. The hard part is keeping an expensive high-speed system full of profitable orders close enough to the customer, with packaging costs low enough and quality controls strong enough. That one problem does not stop millions of bottles at once. And before you can understand whether that works, you need to know what you would actually own. Because the factory, the source, the brand, and the customer relationship may belong to different people. You might own the land, the building, and the machinery. You might lease the building and own only the equipment. Your water might come from a municipal system, an approved well, a spring you own, a spring you lease, or a supply agreement you depend on but do not control forever. The name on the bottle might be yours. It might belong to a supermarket. It might belong to an outside beverage company, using your factory to make its product. That means you can own the physical plant and still rent, license, or contract for almost everything that makes the plant valuable. This matters because bottled water is not one business. A premium source brand sells a story, a package, and a certain kind of identity. A private label factory sells dependable low-cost production to a retailer. A contract manufacturer sells spare capacity and technical capability to somebody else's brand. They can all fill a clear bottle with water, but they do not earn money the same way and they do not carry the same risks. The source itself is the first surprise. Some bottled water does come from springs and wells, but purified bottled water can begin with ordinary municipal water. The plant receives that water, treats it through processes such as filtration or reverse osmosis, tests it, bottles it, and labels it according to what it actually is. So no, owning this business does not automatically mean owning a picturesque spring. And that creates the first useful question. If water is widely available, what exactly are you spending more than $100 million to build? Start with the shell. A serious factory needs industrial land, a large building, heavy electrical service, water connections, or source infrastructure, storage tanks, treatment equipment, pumps, sanitation systems, compressed air, fire protection, loading docks, a quality laboratory, warehouse space, and enough paved access for a constant movement of trucks. Then comes the line itself. The water has to be treated, the container has to be created or supplied. The bottle has to be filled, capped, inspected, labeled, grouped into a pack or case, placed on a pallet, wrapped, stored, and loaded. Every machine has to pass the product to the next machine at the right speed. A failure near the beginning can starve the rest of the line. A failure near the end can leave thousands of finished bottles with nowhere to go. One advanced plant built in Connecticut shows the scale. The facility covered almost 432,000 square feet and involved more than $115 million in capital. It began with 2 beverage lines and later added a third, yet it employed roughly 120 full-time people. The building is enormous. The headcount is not. That is not because people are unimportant. It is because the people are supervising, maintaining, testing, scheduling, repairing, and protecting a machine built to repeat the same motion at extraordinary speed. Commercial bottling equipment can process tens of thousands of containers every hour. Some operating lines handle around 54,000 bottles per hour. Faster systems have processed more than 80,000 smaller bottles per hour. At the upper end, certain equipment can be rated for as many as 100,000 containers per hour under the right conditions. Rated speed is not actual output. Actual output is not sold output. And sold output is not profit. There is another reason the production counter can mislead you. Not every bottle represents the same amount of product or the same economics. A line filling small single-serve bottles can process far more individual containers than a line filling larger bottles. Operating examples show half-liter products moving at much higher unit counts than 2-liter products. The smaller bottle may produce more labels, caps, and handling events for the same amount of water. The larger bottle moves fewer units, but more water each time the filler cycles. So when somebody tells you a plant makes a certain number of bottles, you still do not know enough. How large are they? What package surrounds them? What price does the customer pay? How often does the line change formats? How many gallons moved? How many gallons moved? How much did each case leave behind after delivery? A million tiny bottles may look more impressive on a production screen than a smaller number of large containers. That does not tell you which run made more money. But use a line rated at 60,000 bottles per hour to see what the machinery is demanding from you. Run that line 20 hours per day across 300 production days, and its theoretical annual capacity is 360 million bottles. Now imagine a normal-looking problem. A cap feeder jams for 20 minutes. The next label roll arrives late. A sanitation cycle takes longer than planned. A customer changes the order and the line has to switch package formats. The warehouse cannot accept more pallets because outbound trucks are delayed. None of those events sounds like a crisis. Together, they remove 2 productive hours from the day. At 60,000 bottles per hour, across 300 days, those 2 missing hours represent 36 million bottles of unused annual capacity. The debt still exists, the building is still heated, lit, insured, and maintained. The laboratory still operates. The technicians still have to be there. You simply have fewer sellable units carrying the same fixed burden. This is why owners watch uptime so closely. The factory does not need to look busy. It needs to turn available hours into correctly made bottles that somebody has already agreed to buy. Now move closer to the line, because one of the most satisfying parts of the factory is also one of the most important economically. The empty bottle may not arrive as a bottle. The plant can receive compact pieces of plastic called preforms. A preform looks like a thick test tube with the finished neck already formed. It is heated, stretched, and blown into the final bottle shape. Then, it moves directly toward the filler, sometimes only moments before water enters it. The bottle factory is partly inside the water factory. That solves an obvious physical problem. Full-size empty bottles take up enormous space and force trucks to carry mostly air. Preforms are compact. They are easier to store and move. Making the bottle on site can also give the factory more control over bottle weight, design, quality, and timing. But it adds another expensive machine that can stop the line. That is the trade. Buying finished bottles can require less capital and less technical complexity. Making them yourself can reduce outside dependence and lower the cost per unit when the volume is high enough to justify the equipment. At this scale, almost invisible savings matter. A 1-cent reduction in cost per bottle sounds trivial. Across 300 million bottles, it is $3 million. A lighter bottle, a slightly cheaper cap, less wrapping film, fewer rejects, or a shorter stoppage can move more money than a small company earns in a year. That is why factories obsess over details shoppers never notice. A shopper sees water, a bottle, a cap, and a label. The owner sees resin, preforms, blow molds, compressed air, cap supply, label alignment, case film, pallet patterns, rejected units, and minutes of line time. Now the bottles are moving. The next question is who is paying for them? Picture the same production line on 3 different days. On Monday, the bottles carry a supermarket's name. This is private label. The retailer controls the brand and places a large order. You do not have to persuade the public to recognize your factory. You have to make the right product at the right price and deliver it when promised. On Tuesday, the line produces for an outside brand. This is contract manufacturing. The brand owner brings the name and the demand. Your factory provides the treatment, packaging, and capacity. On Wednesday, the bottles carry your own name. Now you own the brand, as well as the production risk. You may earn more if shoppers will pay more, but you also pay for salespeople, promotion, placement, distribution, and the possibility that the public ignores you. The easiest version to imagine is owning the brand and keeping the shelf price. That is not what happens. The price in the store has to support the retailer's margin. It may have to support a distributor. Promotions reduce what is collected. Warehousing and freight are still waiting. If you own the brand, the money spent creating demand comes out before the owner sees a return. Private label avoids much of that consumer marketing burden, which is why it can produce enormous volume. But the retailer buying that volume has leverage. Large buyers can compare manufacturers, demand lower prices, ask for additional support, and move business when another supplier offers a better arrangement. So the line returns to the production calendar. One retailer occupies most of it. That looks like success. The plant has scheduled volume. The packaging team can order large quantities. The line can run longer without changing labels or bottle formats. The warehouse knows what is leaving. Suppliers know what is needed. Then the retailer asks for the lower price. This is not a theoretical personality conflict. It is a structural negotiation created by the factory itself. You spend heavily to build a machine that becomes more efficient when it runs at high volume. The retailer controls enough volume to keep it efficient. The more you need that order, the more powerful the buyer becomes. You can refuse. Now a large block disappears from the schedule. The line still exists, but the same fixed costs are spread across fewer cases. You can accept. The factory stays busy, but every case leaves less money behind. Or you can replace the order. The available replacement may want a different bottle, a shorter run, a lower price, or delivery to a more distant market. The new business fills the line, but it does not necessarily repair the economics. That is where the visible signs begin to lie. A factory can report more bottles, more cases, and more production hours while becoming weaker. If the extra volume requires too many changeovers, too much discounting, or too much freight, the counter rises while the owner's return falls. A full production schedule is not the same thing as a healthy production schedule. Now follow one finished case out of the loading dock. The factory may have done everything right inside the building. The bottle is light. The line ran efficiently. The cap and label were purchased well. The order is ready on time. Then the case goes onto a truck. Bottled water has a simple physical problem. It is heavy relative to its selling price. A truck can carry only so much weight, and most of that weight is the product itself. The farther the truck travels, the more fuel, driver time, equipment, and route cost have to fit inside the value of a relatively inexpensive case. There is no single profitable distance that applies to every factory. Package size matters. Contract price matters. Fuel matters. Backhaul opportunities matter. Premium products can absorb more freight than low-priced private label, but distance does not disappear because the line is efficient. Draw a circle around the plant. The customers inside the first ring are easier to serve. Add another ring, and freight takes more of the price. Add another, and the owner may be producing impressive volume for a customer that is too far away to be attractive. This is why a network can beat one enormous factory. One giant plant may achieve excellent production efficiency and still lose that advantage on the road. Several regional plants can place production closer to retailers, shorten routes, reduce dependence on one source, and provide backup capacity when one location has a problem. Now return to the retailer that cut the order. The line has empty time. A customer 3 states away offers replacement volume. The price is weak, but the plant needs the cases. You accept. The line starts moving again. The new order uses a different package. Changeovers increase. The trucks travel farther. Fuel rises. The retailer refuses to change the agreed price. The building looks active. The loading dock looks active. The production counter looks healthy. But the factory is now using more of its machinery to produce less useful money. The first loss was volume. The replacement brought volume back. It did not bring the economics back. That is the capacity trap. An expensive machine built for repetition can pressure its owner into accepting weak business simply because idleness is so visible and so costly. And this is the point where the bottle finally tells you what the business really is. The factory is not merely selling water. It is selling reliable, low-cost, locally delivered packaged volume. Water is the ingredient. The customer is buying the certainty that the correct case will appear at the correct distribution center, in the correct quantity, with the correct label, at a price that still works after packaging and freight. That is a much harder product to make. A real company's history shows how powerful this model can become. Niagara Bottling began in the early 1960s with large container delivery for homes and offices. Years later, it moved into single-serve private label manufacturing. That shift changed the scale of the problem. Instead of delivering reusable containers along local routes, the company had to manufacture enormous quantities of small bottles for retailers competing heavily on price. The response was not simply to find better water. The company expanded high-speed manufacturing, worked on lighter packaging, brought bottle production into the plant, and built more facilities across different regions. Private label customers supplied large recurring orders. Vertical integration gave more control over packaging. Regional plants placed production closer to demand. Look at what each move solved. The high-speed line lowered the cost of repetition. The preform reduced the need to move empty bottles. The retailer order filled the schedule. The plant network reduced the distance to the shelf. The company's growth followed the hidden economics of the business, and it also reveals why a factory can be difficult to copy even when the product looks interchangeable. A competitor may have water, it may even have a bottling line, but it still needs efficient packaging, approved sources, customer trust, dependable quality, and facilities positioned close enough to demand. The advantage is not one machine, it is the coordination between all of them. Now imagine that coordination working perfectly on a Thursday morning. The line is running. Bottles are being formed, filled, capped, inspected, wrapped, and palletized. Trucks are booked. The customer expects the order. Then the laboratory places the finished lot on hold. The bottles look normal. The water is clear. The caps are sealed. The pallets are ready. They cannot leave. Bottled water is ready as packaged food. The plant has obligations covering sanitary equipment, processing, bottling, holding, transport, testing, and records. Certain source arrangements require regular microbial testing. A concerning result can trigger follow-up work before the product is released. Now the factory has to answer a different set of questions. Which production window is affected? Is the issue in the source, the treatment system, the bottle, the closure, the sanitation process, the sample, or the records? How many pallets belong to that lot? Does production stop while the cause is investigated? Can the product be released, or has the factory created an enormous quantity of inventory that cannot be sold? At high speed, uncertainty multiplies quickly. That is why the quality laboratory is not an office sitting beside the real business. It decides whether the real business is allowed to continue. The same dependence exists at the source. Water has to be legally available, approved, consistent, and close enough to use economically. An owned spring, leased spring, well, municipal connection, or supply contract can all work, but each creates a different form of control. Permits can change. Source quality can change. Drought or local restrictions can reduce access. An alternative source may exist, but bringing water from farther away can add cost and operational pressure. Packaging rules can change as well. Some jurisdictions require covered beverage containers to use a minimum amount of recycled plastic. Retailers may impose additional standards. A plant built around one package cannot assume that package will remain unchanged forever. The product looks permanent. The operating permission is conditional. So, does owning a bottled water factory work? In the strong version, the answer is yes. The plant sits near major demand. Its approved water supply is reliable and has a backup plan. The line is modern and used heavily, but not recklessly. Production runs are long enough to limit changeovers. Packaging is purchased efficiently or manufactured inside the plant when scale justifies the investment. No single customer controls the entire schedule. Contracts provide some protection when major inputs change. The quality system catches problems early. Debt is manageable enough that 1 weak quarter does not force the owner to chase any order available. That factory can become extremely durable. Demand is broad. The product is familiar. Automation allows a relatively small workforce to produce extraordinary volume. Small improvements multiply across hundreds of millions of units. A retailer that depends on nearby reliable production cannot replace the plant as casually as a shopper can replace one bottle with another. Now put an identical bottle above the weak factory. The building was purchased at the wrong price. The equipment is old and stops often. One customer controls most of the line. Every new order requires another label, cap, or package change. The source agreement has no easy backup. The plant sits too far from several customers. Resin and fuel rise while contract prices remain fixed. The owner accepts distant discounted work because the empty line is impossible to ignore. The bottle reaches the shelf. From the outside, the business looks alive. Inside, the factory is spending more of its capacity to defend less of its margin. While one customer, one source problem, or one quality hold can remove the small amount of room that remains. That is why two factories can sell water that looks almost identical and produce completely different outcomes for their owners. The shopper sees a simple product because the complexity has been hidden upstream. You would see the building that has to stay full, the machines that have to stay synchronized, the package that has to become lighter without failing, the source that has to remain approved, the customer that has to keep ordering, the laboratory that has to release the lot, and the truck that has to reach the shelf before distance consumes the margin. So when you imagine owning a bottled water factory, do not picture yourself owning water. Picture yourself owning a promise made hundreds of millions of times. The same safe bottle, the same correct label, the same delivery, the same low cost, again and again close enough to the customer that the system still works. The water is what fills the package. Keeping that promise is the business.